Hello friends, my name is Kumar and welcome back to our channel Kumar Programming. Today from our JavaScript interview question answer series, we are going to learn about lexical scoping and closure. Lexical scoping and closures are very important from the interview perspective as well as coding perspective both. If I ask this question to the candidate, believe me, 70% candidates are saying that we are not aware about it or they are not able to give the proper answer. From the name, it looks like it's very complex, but believe me, it's very simple. At the end of this video, you are going to completely learn about lexical scoping and closure, and you will be able to answer to the interviewer in detail. And you won't be having any doubt about lexical scoping and closure. Why we are having this both lexical scoping and closure together? Because lexical scoping is a part of closure, or you can say closure use lexical scoping. Okay, so if we understood about the lexical scoping properly, then we would be able to understand easily closure as well. So that's why we are having both of the topics together today, and eventually we are going to have the practical demonstration in order to understand in a better way. So now let's start. So what is lexical scoping and closure in JavaScript? Now let's first understand the definition. Lexical scoping is also known as static scoping. Okay, and it is a scoping mechanism where the scope of a variable is determined by its location in the source code at the time of its compilation. And it is based on physical structure of the code and the nesting of functions. What does it mean? So let's understand with the diagram. Here if you see the complete green zone I have considered as a global or script scope, and the yellow zone that I have considered as a local or function scope, and the red section that I have considered as a block scope, right? Now come to the point here. So suppose that here I have created a variable as a inside our global scope, then this a variable will be accessible in our local scope as well as this will be accessible in our block scope both. Okay, and if we have declared a variable inside our local scope, suppose that here I have created a variable b, then this b variable will be accessible throughout this local scope as well as it will be accessible inside this block scope as well, right? And if I have created a variable c inside our block scope, then this c variable will be accessible inside this block only, right? And this c variable will not be accessible inside the local block as well as inside the global block. Okay, and each and every block, this local scope block, global scope block, and block scope, right? Each and every block is creating a lexical scope. So here we have one lexical scope, and here we have another lexical scope, and this is a global lexical scope, right? And this whole things is known as a lexical environment. Okay, now let's understand with the code. So if you see here, I have created a variable a, and then after that I have created a function first. So this a variable is created inside a global scope, right? So this is my global scope, and then after that I have created a function here, and this function is having its own scope. Okay, and then after that inside this function I have created another function which is having its own scope, right? So if you see here, we have three scope. This is my global scope, and this is my local scope, and this is my block scope, right? So these all scopes are a lexical scope. Okay, and if we declare any variable in the parent scope, then this variable will be accessible to the all the child scope, right? And if we declare a variable b over here, then this b variable will be accessible to the this child scope, right? But if we declare any variable in the second in this scope, in the block scope, then this c variable will not be accessible to the any outer scope. So only the variable scope is flowing from top to bottom, from parent to child. Okay, so that is known as a scope chain, and these scopes are known as a lexical scope, and these variables scope are determining on the basis of their position where exactly they have declared, and that mechanism is known as a lexical scoping, right? And here if you see, I'm trying to use this b variable which is lexically scoped from our local lexical scope, right? So what will happen? Our JavaScript engine will try to find first of all in this scope, right? And if it won't find inside this scope, then it will try to find out in our parent scope. If it will get the value from the parent scope, then it will print over here. If it won't get the value from the parent scope, then it will go to the global scope, okay, next parent scope. And if the variable is declared over here, then it will print the value over here, right? Like see here we are trying to access a variable, so a variable is not in this scope, so it will check inside the parent scope, right? And inside the parent scope also it's not declared, so it's going to be further check with the global scope, and our JavaScript engine will find out the value over here, right? So it's going to be access inside this our block scope, and this process is known as a scope chain resolution. So friends, I hope that you are understanding about the lexical scoping and what is lexical scope and lexical environment and what is scope chain and what is scope chain resolution. Now let's see the practical demonstration. Let's flip to the Visual Studio. So here in our previous video, we have learned about where, let and const keyword in detail, and also we have seen about their scoping. Now let me create another file over here inside the basic itself, lexical underscore closures.js file. Okay, now in this file, I'm going to use the same code that I have explained. So see here in this global scope, I have created a variable a, and then I have created another function inside this global scope, that is a function first, and then inside this function I have created another function as a function second, right? So these all are the lexical scope, right? And this a and b variable are lexically scoped inside this child block, right? If you try to access this c variable inside this block and this block, then c variable won't be able to accessible, right? So always our scope access flows from top to bottom, and that is known as a scope chain, right? And if you try to access this a variable from global access, so first JavaScript engine will check inside this block, and if it won't find, then it will go to the parent block, and if it's not declared inside the parent block, then it will go to the global block, right? And if the variable is declared inside the global block, then it will accessed over here, and that process is known as a scope chain resolution. And the scope of each and every variable is determined on the basis of their location where they have declared, and that process is known as a lexical scoping, right? So now let's run this. Let me run this current file. Now here you can see hello Kumar programming. So here we are printing our a b c, all those three variables, right? And if you see, if I'm trying to access this c variable outside of this block, see this c variable is having scope inside this function only, right? If I'm trying to access the c variable outside of this block, then it won't be able to accessible, right? Now let's see, it should be giving error. Now we are getting a c is not defined. So this c variable is not getting accessed by its parent scope, right? So always our variable are getting scope from our parent to child, not from child to parent, right? And if you see, if we try to access this variable a over here, then we will be able to successfully get the value of a. And if we try to get the value of a and b over here, we would be able to get the value of a and b as well, right? So now let me run this. See, for the this a is declared as a global scope. So here we can see a is as a hello, and here you see inside this first block we are getting the value of a and b both. So here we are having our hello Kumar, and the innermost block that we are having access for a, b and c, all the variables. So here we are getting the value of hello Kumar programming. It's easy, isn't it? So friends, I hope that you are understanding about the lexical scoping. Now let me quickly explain it once again. So we know that we have a global scope and local scope and block scope, right? So if any variable is declared in the global scope or parent scope, then that variable will be accessible throughout all the child scope. And each and every scope is known as a lexical scope. And this whole environment where all the lexical scope resides is known as a lexical environment. And if we declare any variable in the child scope, then that variable will not be accessible to any of the parent scope. So our scope of the variable always flow from top to bottom, from parent to child, but not from the child to parent. right? So here each and every variable is going to be accessible through its all the child scope, and that is known as a scope chain. And whenever we are trying to access any variable that is lexically scoped from the parent, then first our JavaScript engine try to find out that variable in its own block, and if it won't find, then it try to find out in the parent block, and if it's not there, then it's again try to find out parent block, and if it's available there, then it directly getting access from parent block, and that is known as a scope chain resolution. And the lexical scoping is the mechanism where the scope of the variable is determined by its location where exactly they have declared. Now let's further understand about closure. Closure are very important when we are working with a design pattern and when we are required for state management. So now let's see first of all what is closure. So closure, it is a function that closes over the variable from its outer lexical scope, even after the outer scope has finished the execution. And closure capture the lexical scope in which they are created. What does it mean? So basically closures are the function which is using the outer lexical scope. That's it. Or we can say when we are declaring a function inside a function which is using the scope of their parent lexical scope is known as a closure. Now let's understand with the code snippet. So see here, I have created a function, outer function, and inside this function, I have created a variable, outer variable, and again I have created another function inside this outer function, which is a inner function, right? And this inner function is using outer variable that is from our parent lexical scope, right? Because if you see outer variable is not declared here, it is declared inside the parent function. So this inner function is a closure function, right? So from the definition, a closure is a function which is using the scope of its parent lexical scope or outer lexical scope is known as a closure. And closure capture the lexical scope in which they are created. So now here we are returning this closure function from our outer function. So here we call outer function and it return a closure function, right? And if we try to execute this closure function, then it return the output I am from outer function. So this function is maintaining the state of this outer variable inside the closure function, right? So in short, closures are a function which is written inside a function and accessing the scope of its outer function or its parent function, right? Now let's see in the Visual Studio. So here in our previous video, we have learned about the lexical scoping. Now let me create another file here as a closures.js, right? And here I'm going to use the same code snippet that I have used earlier. So here you can see I have created an outer function, and then in this outer function, I created a variable, outer variable, and then inside this outer function, I created another function that is an inner function. And this inner function is accessing the variable from our outer lexical scope, right? And we are returning the inner function from here. Now here I'm trying to call this outer function, and once we call this outer function, it returning the inner function, and this inner function is nothing, this is the closure function. So this inner function is closure function. And even though if you see here outer function execution got completed, but still this closure function is having the access of this outer variable or maintaining the state of this outer variable. Now let's run this quickly and see. So here I'm going to run this, run current file. Now execute this. See, I'm getting the output as a I am from outer function, right? So now here if you see, here the execution of the outer function is already over and it returned the closure function. And when we try to execute this closure function, but still this is having the access of this outer variable. So this is known as a closure, and maintaining the state of the variable from the outer lexical scope is make it very, very important and unique feature. And that is widely used in our design patterns. Now there would be a question coming in your mind like where we can use these closures, right? Our interviewer can ask you in a different way, what are the uses of closure, or where we have used closures in your project, right? So now let's see what is the use cases of closure we have. So mainly closures are uses for the data encapsulation and privacy, and also it is used to create the factory pattern, and it is also used as a callback function as well, and it is used in modular pattern as well. And the very most important that which I like is memoization, and closure is used for the memoization, and we will see each and every use cases and how we can implement them. Now let's first of all see the data encapsulation. So now here if you see, I've created a function as a counter and I have set a counter value as 0, and then I'm returning a function which is a closure function, and inside this function I'm incrementing the count variable, right? So if you see here, once I'm calling this function counter, it's returning another function, and that function I have mentioned as a name as an increment. And whenever we are calling increment function multiple times, it return the output 1 and 2. So it maintain the status of the count for each and every execution. So in this way, we can achieve our encapsulation and privacy of the data. Now let's see the second one. This closure is being used as a function factory or factory pattern. So here if you see, I have created a function as a create multiplier, and inside that I'm passing a parameter as a factor, and then I'm returning a function from this function which is having the multiplication of number and factor, right? And here we can pass this parameter, different parameter, and on the basis of those parameter we can return it here multiple functions, right? So this can be used as a function factory or factory pattern. Now let's see the third one, which is callback functions. So if you see here I have created a function do something asynchronous, right? And inside this function, I'm passing a parameter as a callback function, right? And inside this function, I'm executing some fetch data from server, some backend process, and I'm getting the result back. And then I'm passing this result to the callback function, right? So now here see, so here I'm executing do something asynchronous function, and inside this function, I'm passing a function parameter, right? And this function is going to return the data. The result which we will get it from here, it's going to log inside our do something asynchronous function. Okay. Now see the third one, which is module pattern. Now here you can see I have created a module 1, and inside this module I have created a function, and then inside this function I'm using a private variable, and also I have created another function which is a private function, and then I'm returning a public variable and a public function, and I'm calling this private function inside this public function. Okay. So here you can see this, I have enclosed this function inside a bracket, and that is nothing. This is a ify. Ify is a immediately invoked function expression that I'll cover in a separate video. That is also a very important topics from the interview perspective. So now let's come to the point here. Here I have created a function, and inside this function I'm returning another function as a public function. So here from the module, user will be able to access only the public variable and public function. User won't be able to access this private function and private variable, right? So this closure is very useful in our module pattern as well. Now the last one is memoization, which is my favorite one. So if you see here, I have created a memoized function, and inside this function, I have created a variable type of object as a cache, and then I'm returning a function from here, right? And inside this function, I'm checking this if the passed parameter is in the cache or not, right? If it is in the cache, then it's going to return the value. And if this value is not in the cache, then come into the else part and do the some expensive computation and then store the result inside the cache, right? So basically this memoization is used whenever we have some type of expensive computation or time consuming computation. In that case, we are caching all those result inside our cache, and whenever we are required that value again, then we are getting it back from the cache rather than executing it once again, right? So this closure is very useful in order to achieve the memoization. So here if you can see, I am calling this function memoized function, and then I have returned the memoized, right? Memoized, this memoized is the closure function, and once I'm calling this closure function with value 5, then I'm going to call this function, I'm going to return the value and going to store inside the result. And second time once I'll call this function with the same argument, then it's going to get the value from the cache rather than calculating it once again, right? Now let's see the practical demonstration for all of the use cases. Let's flip to the Visual Studio. So here I'm going to use all the code snippet here which I have shown it earlier. So I'll show you one by one here. As of now, I'm going to just comment for this closure, and I'll comment it for the other as well, right? Now, as of now, I'm having only for the data encapsulation. So since already I have explained this code, we have a counter function, and inside this function, I'm returning another function from here, right? So now let me execute it, run the current file. Now see, here we are getting the value 1, and here we are getting the value 2. If you see here, counter function, this execution of this counter function is already completed, but still whenever we are calling increment function, we are getting the result as a output 1, and the second time when we are calling the increment function, we are getting the output as a 2, right? So in this way we can achieve the data encapsulation, privacy, as well as maintaining the state of our lexical scoped variable, right? Now let's see the second one, how we can use it as a function factory. So let me comment it for now and uncomment for this function factory. Now here you can see I have created a function as a create multiplier, and inside this function I'm passing a parameter as a factor, and I'm returning a function which return the multiplication of number and factor. However, on the basis of this factor, we can create a multiple function from here, right? Now suppose that here we have if factor is less than 10, then we should return this function, else we can return number into factor into 2, right? So on the basis of this parameter, we are returning the multiple function from here. So now I'm calling this create multiplier function by passing parameter as a 2, and which is returning as a closure, and then eventually I'm passing parameter 5 to the closure. I'm getting value as a 10. So now let me run this and show you. See, now I'm getting the value as 10. But if I pass this value as a 12 here, then we should be getting 12 into 5 into 2, so it would be around 120, right? See, now we are getting as a 120. So in this way we can create the multiple function, and on the basis of the parameter we can return those functions, and we can create a function factory. Now let me comment it and execute for the callback function here. So our third use case is that closure can be used as a callback function. So here I have created a function, and inside that function I'm passing a callback, right? And here fetch data from server, I have not declared this function. So let me just declare this function inside this function itself. So what I can do here, I can create a function inside a function, fetch data from server, and I can return some value from this, return math dot random. Okay, some random value I'm getting it from here, right? So here we are fetching some data from the server, and we are passing that result inside our callback function, right? Further we are calling this function, right? And once we are calling this function, we are passing a complete function inside this, right? And this function itself having its functionality, it's we are passing the data to the function, and then we are logging that data. So here we are using closure as a callback, right? So now let me run this. Now see, here we are getting the log, and this is the output generated by this math.random function. So friends, I think that you are getting it now, but still if you are having any doubt, you can comment me at any time, and I'll try to get back to you on that as soon as possible. Now let me comment this and see for the module pattern. Now another use cases is this can be used as a module pattern. So if you see here, I have created a module, and inside this module I'm passing a function, right? And whenever we are enclosing a function inside the bracket and calling this function, that is known as a IFE, immediately invoked function expression. And see, from this function I'm returning a public function. So here once we have provided this module to the user, so user will be able to access only module.public variable and public function. User won't be able to access this private variable and private function. So in this way we can achieve this module pattern by using our closure. Now let's see the final one, which is memoization. So now let me just uncomment it. Now if you see here, I have created a memoized function, and inside this function I'm returning another function from here, right? And this function is having a parameter as a arg, and we are first of all we are checking if this cache is available inside this arg or not. If it is available, then it return the value from the cache. Otherwise we can proceed for the expensive calculation or time consuming calculation, right? So here what we can do, like, so for now just let me use the date dot now function, so it will return the current date, right? And once we call this function, it return a function which is a closure function, and we are calling this closure function. First time it will execute from here, and second time it will execute from cache, right? So now let me show you here. I'll go to the if block as well as I'll go to the else block. Okay, now let me run this. Now see, I'm calling this function memoized function. Now execution for this memoized function is completed, right? Now this function return a closure. Now from the closure, I'm passing value as a 5. So once we pass the value 5, it went inside this function and it checked if it is available inside the cache. So first time it won't be available. So it will go to the else block and it will store the value inside the result. But whenever we are calling the function second time, so it goes to the closure function once again, and this time it will get the value from the cache. So see here, now the value is available inside the cache and it's going to fetch from the cache. And now we get the same data. Now if we call this function with 6, then it's going to have a different value, right? So whenever we change the argument, the value in the cache is going to be added for that particular argument. So friends, I hope that you would be able to understand that what is closure and what are the use cases we have for the closure. I have provided this code to my GitHub and link is given below in the description. And still you are having any doubt, please comment me or message me and definitely I'll try to get back to you on that as soon as possible. So now this come to the end of this video. For more video, you can subscribe this channel and like and share to the whatever the social media platform that you are using. So that's all for the day. I'll see you in my next video. Till then, take care and keep learning.